In this section, we are going to discuss virtualization tools in GNU Linux. When I taught the RHCVA course for Red Hat as a Red Hat certified instructor, the question I received many times was, how much Linux do you have to know to become a Red Hat certified virtualization administrator? My answer is that you didn't have to know much, but that any foundational knowledge you had of Linux was going to help you as you administer virtual machines. The Red Hat Certified Virtualization Administration exam mainly tests knowledge on how to use Rev and the utilities that are provided for it, such as Rev Manager. Since Linux is the foundation of what happens in Red Hat Enterprise Virtualization, we're going to take a look under the hood at KVM, kernel-based virtual machine. Although the objective of this exam is to test the ability to use Red Hat Enterprise Virtualization to implement Linux virtual systems, it is not a test of system administration skills. Red Hat does recommend prior Linux system administration experience. That is directly from the RHCVA exam objectives on redhat.com. I feel that my answer to the question above aligns perfectly with the statement that Red Hat made on their own site. While you don't have to know Linux to certify as a Red Hat Certified Virtualization Administrator, everything you know will help. So consider this course a look under the hood. KVM is what is powering Red Hat Enterprise Virtualization. So we're going to take a closer look at the utilities that Linux provides for us to manage virtualization on a Linux system. Linux is able to connect to almost any hypervisor. There are tools within Linux that allow you to connect to VirtualBox, Xen, VMware, and other hypervisors. The built-in tools on Linux are going to also provide virtual viewers, which will allow you to graphically access your virtual machines. If you're running without graphics, it'll give you a console. Even if you're not accessing through the virtual viewer, you can also access through an API. Developers configure API libraries to manage systems programmatically. The API hooks that are available in Linux virtualization are extensive. If you'd like to directly access your virtual machines using the command line, you are able to administer all of your virtual machines with every resource from the command line. You are able to do more with the command line in Linux than you are with any of the other tools combined. The advantage of virtualization management software is that you're able to centralize all of your resources into one place. This is not just convenient for an administrator. It is necessary when you're deploying thousands of systems in an enterprise environment. A lot can be said about the different types of virtualization and their capabilities, but anybody exploring an environment for their virtualization should know that Linux is great for running virtualization. The only arguments I've heard against Linux are from people who are heavily invested into some other technology. I've heard some who use VMware criticize Linux because it runs on top of a kernel. What they might not know is that VMware also runs on top of a Linux kernel. It's a modified Linux kernel called VMNix. It doesn't get much publicity, but that's how it works. Xen Server also runs on a modified Linux kernel, which begs the question, why are the top virtualization hypervisors running on the Linux kernel? The answer is that the Linux kernel gives you the most capabilities using the fewest resources. Using a Linux kernel also gives you complete control over your hypervisor. There are many tools that are available through Linux to assist in the administration of virtualization in Linux. One of those tools is Virt Manager. Virt Manager gives you a graphical view of all of your hypervisor connections and all of the virtual machines running in those hypervisors. If you simply click on one of those virtual machines, it activates a virtual viewer or Virt Viewer, which will give you console or graphical access to your virtual machine, depending on what kind of install you've chosen. Another tool is Virt Install. Virt Install lets you do command line installations of virtual machines. This is great for scripting the creation of virtual machines as well. This allows administrators to test the configuration of their virtual machines before they deploy them into production environments. Another useful tool is Virt Top. Like the top command in Linux, Virt Top shows you the resources that are used by a specific virtual machine. KVM has the ability to convert other disk image formats into one that is compatible with KVM. The program used to do this is Virt V2V. Other disk images include VirtualBox's disk image, Virtual PC hard drives, parallel hard drives, and the QEMU formats that are used also in Linux. If you have a physical system that you'd like to turn into a virtual machine, there's a utility for that as well. Virt P2V is a live image that runs on a physical system, gathers information about that system, and creates a virtual image from that system. Once you have the virtual image, you can run it in your virtualization. libguestfs is the collection of tools that includes virtv2v and virtp2v. It includes many other resources for you to use as you administer your virtual environment. So that you know what's going on in the background, I show you the description from virtv2v and virtp2v. It says, virtv2v and virtp2v are tools that convert virtual machines from non-KVM hypervisors or physical machines to run under KVM. Everything that happens in the background with Red Hat virtualization in Rev is KVM. That's why I feel like it's important to take a look at this. It will help you understand how your system is running later on. It will help you to better administer Red Hat Enterprise Virtualization. In summary, KVM is what's under the hood for Red Hat Enterprise Virtualization. Learning more about KVM and Linux will only make you a better administrator of virtualized systems. Being familiar with the tools that are available to you may be the difference in solving future problems.